5.2 Conservation of momentum in one dimension. So love the conservation of the energy we had, that energy is not created nor will be lost, just is turning from one form to another form is the same thing. If the net force acting on a system interacting object is zero, then the linear momentum of the system before the interaction equal the linear momentum of the system after interaction. When we say interaction means collision. So when you have two objects, the total momentum before the collision, let's say just look at this object before the collision, this is moving with some velocity, this is m2 moving with some velocity. The total momentum is mv1 plus m2v2. Make sure that velocity 1 here is positive, velocity 2 is negative. And you equal it to the momentum after they interact. So this picture stays after colliding, so they just moving away from each other with different velocities. So this is what we have, m1v1 plus m2v2 is equal to m1v prime. When it says v prime is after collision, plus m2v prime. This is the velocity after collision. Total momentum before collision and after collision is the same. So look at this question. A person mass 75 kilogram is standing on a stationary raft of mass 55 kilogram. The backhancer then walked toward one end of the raft. So before of interaction, both were not moving. And after collision, one is moving with 2.3 meters per second. What are the magnitude and direction of the resulting velocity of the raft relative to water? When the person is moving forward, the raft is moving backward. But before they move, both of them velocity is zero. After they move, person is moving forward, the raft is moving backward. As you move forward, you push the raft backward. So we establish the conservation of momentum equation. So m1v1 plus m2v2 equal to m1v1 prime plus m2v2 prime. So knowing that before both of the person and raft velocity is zero, so these two terms zero, and after the person is moving with 2.3, so v1 prime is 2.3. The mass of the person is 75. The mass of the raft is 55. You just need to solve for v2. You arrange it for the v2 prime and just put the numbers, you get that negative 3.1. Here is another question. During a baseball game, a fullback of the mass 108 kilogram right running at 9.1 meter per second. So this one running with that speed, and it's head on by a defective back mass of 91. So this one, the mass is 91, and the speed is negative 6.3. So it should be, you need to consider the direction of the movement because the vector is velocity. Velocity is a vector. What is the speed of the pair just after collision? When they come together, they are stuck together and they move with some velocity. Both of them has the same velocity. So we establish conservation of the mass. So we want to find, so this one, the m1 and m2 different, but v prime, they moving with the same velocity because they stuck together. You can factor out this v, then you rearrange it for that v prime. So divide both term by m1 plus m2. Mass 1, 108 multiplied by the velocity of the first person plus mass 2 multiplied by the velocity of the second. Make sure you consider the direction of that velocity. Divide by m1 plus m2, we do it, and the final velocity is 2.1 meter per second. We can try question 3, 4, 5, 6, 7, 8, and 9 as a practice.